Okay, notice in this next problem there are two equations with three unknowns. So we really have two planes, and unless they're parallel, and I don't think that one is a multiple of the other, I don't think we've got any problem with that. Unless they're parallel, there's going to be a line where these two planes intersect. Now they are asking us to use Gauss-Jordan elimination. I don't know that this would be my first choice here, but I'm going to rearrange these rows as I write it in a matrix form, and write the 1, -2, -7, -12 first, followed by 2, -1, -5, -3. And the goal is, let's get that 1 in the top left corner, which we've already done, and then get the 0 beneath it, which means we will go -2 row 1 plus row 2 is the new row 2. The first row stays 1, -2, -7, -12. The bottom row now becomes 0 for starts. Here we go. -2 times -2 is 4, plus the -1 makes 3. -2 times the -7 makes 14, plus the -5 makes 9. -2 times -12, that's 24, minus 3 makes 21. Okay, now we want to get a 0 where the 3 is, and that means we're going to multiply by 1/3 on that row. So 1/3 row 2 will become the new row 2. First row is going to stay 1, -2, -7, -12. The next row becomes 0, 1, 3, 7. And we wish to get the 0 where that -2 is. We cancel out a -2 with a +2, so we will go 2 row 2's plus row 1 is the new row 1. Rewriting this, we have the 1, 0, 0, 1 the way we wanted to keep it. The bottom row is going to keep the 3 and the 7 because that row will not change. And here we've got to figure out the rest. 2 times row 2. 2 times the 3 is 6, minus that 7 up there is -1. 2 times the 7 is 14, take away the 12, there is 2. Now there's no more reducing we can do here. Basically we can rewrite this system as x minus z equals 2 and y plus 3z is equal to 7. And again note that both x and y are in terms of z. I can rewrite the first equation as x equals z plus 2, and the second equation as y equals -3z plus 7. So I'm going to choose to write this in a parameterized form as the set of points where x is going to be the z plus 2, y is going to be the -3z plus 7, and z will represent itself where z is any real number. Okay, another dependent system. We probably do not want the fractions and the negatives here, so I'm going to choose to multiply that first equation through by -1. I notice everything here is a multiple of 10, so I'm going to choose to divide by 10. And I'm going to multiply this next row by -7. When I do that, the first row becomes x minus 2y minus 7z equals -14. Second equation dividing by 10 gives me x minus 2y minus 7z equals -14. Hey, same line. And the third one, when I multiply through by the -7, I get x minus 2y minus 7z equals -14. So basically, all three are the same plane. And that means my answer is going to be a plane, and we write this as the set of all points x, y, z, such that, and we choose one of our three original equations, or maybe this cleaned up form here that we have, x minus 2y minus 7z equals -14. And that will be the equation of the plane.